Yeah, hi everybody. Jim Bollinger again, NMH. Let's see if I can put this back a little bit. I've changed the board's position so we don't get that reflection on the board. This is going to be Quadratics Tidbits Part 2. Just some very quick layering of understanding, hopefully, going to present to you here as to why you can take that shortcut with minus b over 2a. Talk about that a little bit, talk about cleaning the square process a little bit, and then we'll get one practice at the end. We'll do, one of those y-intercept, rate of change at that instant, vertex, bang. All right, let's get to it. All right, so here's your typical table. Minus 3 gets you 9, minus 2 gets you 4, you're squaring. And you'll notice that at 0, 0, we have a kind of an important critical, I'll call it critical, data point. That's different than the rest. If you'll notice, you've got some pairing here of y values that get the same y value when you put a different input in. That doesn't happen here. That's alone. And what is the significance of 0, 0 in this? Well, it's the vertex, right? And so therefore, that is a minimum. That's a smallest value, okay? Just like when I throw a marker up, there's a maximum. That's a quadratic relationship, by the way. We'll get into that later. So let's just look at a typical quadratic, fancy word for rectangle. In factored form, x squared plus 6x, x times x plus 6. And, x is a variable distance, so maybe it was something like this, where my x is a little bit smaller than it was a second ago. All right, we can change that into the graphing form by shortening the longer side, making the shorter side longer. So x plus 3 times x plus 3 is x squared plus 6x plus 9. And we have to get rid of the 9 in order to get back to what we started with. So these are identical. These are identical statements in terms of how inputs, outputs, identical table values. And then just calculation just expressed a little differently. So what is this? This is, we're not going to go around drawing squares. So cut to the chase. There's the picture of x squared plus 6x, right? Minus b over 2a, minus 6 over 2, which is negative 3. What happens when you put negative 3 in? Negative 3, oh, there's nothing here, so therefore that's the minimum value. This is the kind of stuff we're playing with. Okay? All right, so let's put something in graphing form. Probably talked that through a little too quickly, but you can go back and play it again. I'm a fan of repetition, right? So let's put something in graphing form. Let's say we got 2 times, I like the number 3, so x minus c squared plus 5 equals 0. So how would you solve that for 0? Finding the roots here, obviously, finding the roots. What's this quadratic look like? Very quickly, 3, 5. Put a 0 in. You got yourself 18 plus 5, 23. So I got a y-intercept way up here. All right, so it's something like that. And so we can see that the roots are imaginary. And where does that come from? Well, whatever this y value is, step 1, you have to change the sign. Okay, see that? That makes a little more sense than the last time I did it, I hope. And then you got to do what? Oh, you got to divide by a. Right, so you got to get rid of that. You got to get rid of that. What do you got to do with the square root? Right, you got to get rid of squaring, which is plus minus square rooting. There's your imaginary. All right, and then, of course, you got your 3 right there. All right, and that's what you have to do to imagine that you going in the other direction. I know that textbooks say it's a third axis I, but I think envisioning this flipping gives you a better sense of the actual numbers at play here. You're just doing a sign change. And I squared is a sign change mechanic, right? Okay, eventually you're going to square some i's in here. All right, and we talked about that in the last video a little bit. Now let's get a little practice in. So let's see if we can get a little better at seeing the whole picture. So we got a function here. Let's just go. Let's know 2x squared plus 3x plus 5 equals 0. Okay? Obviously, if all you're doing is finding the roots, I think you just find the y value of the vertex and then go from there. But let's do the whole thing. So you got a y-intercept 0, 5, going up at 3 to 1 at that instant. So we already got a picture here. We got a 3 to 1 instance at 5. So here's 0, 5. We're going up at 3 to 1, and obviously it's cup shape up. So we got some kind of vertex here that we have to find right now. And so how do you do that? Well, okay, minus b over 2a. I'm going to come back to this. All right, let's look at ax squared plus bx plus c equals 0. Because of the symmetry of this, I'm going to get rid of, not this particular one, but in general, I'm going to solve this. How do you solve that? X times ax plus b equals 0. The easiest way to solve that's factoring. And so we got two roots at what? At minus b over a and at 0. Okay, not necessarily have to put it on this side. Okay, and we know we've got a what? Cup shape. Well, we don't know if this is positive or negative, but we got a cup, generally speaking, cup shaped graph. All right, so where is this? What's the average of the two roots? Minus b over a plus 0 divided by 2. Well, that's minus b over 2a. It's another reason you can find the x value of the quadratic. Just another perspective. There's others, right? There's others. I could show you in class, but let's just keep going here. So back to this. So, okay, so we got a 0, 5. We're going up to 3 to 1 at that instant. So we're going to do minus b, 2a, 3/4, so minus 3/4. Going to plug in minus 3/4 right here. Got to stop again. All right, so let's look at x minus 5 times x minus 5. All right, so when do we get a 0? When you put a 5 in, right? That's going to give you the minimum value here. So if we put a 5 in, we get the minimum area of a square, which is 0. All right, let's put a 5 in. Let's put a 5 in. And let's look at the squared term, 25. The linear term, minus 25, minus 25. Well, that's minus 50 for the middle term. So for the x squared minus, what was it? 10x plus 25, right? That's what you get when you square x minus 5 squared, right? You get that. What do we got here when we put 5 in? We got minus 50. What do we get when we put 5 there, 25? When you add those together, what do you get? Half of that. Or if you prefer, change the sign of the first term. Maybe that's quicker. I don't know. I've, over the years, just evaluated this and cut it in half. All right, so that's where we're at right now. We're at minus 3/4. So minus 3/4 is the x value. You can cut it in half, call it minus 3/8 right now. Or you can multiply minus 3/4 times 3, which is minus 9/4. And minus 9/4 cut in half. In other words, multiplied by a half. Minus 9/8. Okay, so it's not hard to do that with practice. So minus 9/8 plus what? 48? Minus 9/8 plus 40 over 8. I believe I'm in the right ballpark now. Minus 9/8, 5 times 8, 40. Yeah, it's 31/8. So our vertex is minus 3/4, comma 31/8. That's what? Close to 4, height of 4. So this thing didn't drop down much because, you know, once you get past 1 unit of change, 3 and 2, you get to 2, 6, and 8. I mean, this is already taken over. So you wouldn't change very much. All right, so what's the, what are the roots? Okay, so remember we're over here somewhere. So what are the roots? Well, you got to go down that amount, right? And you got to 3/4 plus or minus. The square root's going to come into play. We know this is imaginary. And we still have to divide by the coefficient. In this case is 2. So that makes this 16. Those are your roots. Okay, so that's where you're boom, 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 crossing the x-axis in an imaginary way. All right, now, of course, you could have written this as the square root of 31 over 4. You can start to see the quadratic formula come out of this. But it didn't take me long to get there. I mean, I was talking with you. Guys, probably a 30, 45-second situation here. Let's just find the roots. If that's all you had to do on the SAT or a test that I give you, let's just find the roots of a quadratic right now and see how hard it is without the quadratic formula. Now, of course, anytime you get a square root of a perfect square, you could have factored the problem. And I don't want to get away from factoring. It's a very important skill. But sometimes it's easy just to, so let's do 2x squared plus 5x minus 7, something like that. All right, so minus b over 2a minus 5/4. Going to cut that in half, so we now know minus 5/8 times 5 is minus 25/8. minus 56/8 gets me 70/81 minus 81/8. So I'm below the x-axis, so I've got to go in the other direction. Boom, I got to divide by 2, which makes it 16. And I got to take the, okay, so that should work. I don't know, I might have made careless mistakes. Still fairly early in the day here. I haven't had my first coffee. But that's just a little addendum to the, I'm sorry I talked so fast today, but I got a meeting coming up soon. So I just want to throw something out there, and I just did. Everybody have a nice day. All right, bye-bye.